Thank you all for being here bright and early in the morning. I figure this is like engineering time, right? We have a lot of engineers in the room, scientists. I'd say in full disclosure, as I was reading my bio, I actually started as an aero-astro major at MIT, but I ended up somewhere along the way making a diversion and ended up going into civil engineering with a transportation focus. But I'll always maintain my deep interest in love on the aviation, aeronautics space overall. Actually, my first research was on carbon fiber for wings on airplanes. I did that through my time at MIT. So I want to first just acknowledge maybe the question, like, why someone from the Department of Energy? Sometimes people tell me they're surprised. Are you from DOT? And give you a little perspective of why at the Department of Energy we have a big focus on transportation. So first, when you put transportation and energy in context, when you look at all the ways we use energy, transportation is actually the largest end use of energy, just ahead of industrial use. So you think if we have energy we use for a lot of things in our lives, transportation is actually the single largest use. It's the second highest expense for a typical American household today after housing itself. It is a key part of the economy. About 10% of all jobs are touched by transportation, including you think about all the way goods get to stores, to your house, package delivery, warehousing, car industry, aviation industry, et cetera, maritime. So it is a big part of the economy overall. At DOE, tell you a little bit of our focus. My team, the real job we have is how do we develop more choices for people, more energy options for people that are affordable. At work, they got to get people to where they need to go, whether you're, the plane's got to fly or you got to get to school in the morning, right? You need choices that work for you. They got to be practical. For businesses, they have to be practical to implement. They have to be scalable. We're the U.S. Department of Energy. We're focused on national, large-scale issues. A lot of what we do and a lot of our focus, I listed there our 4 pillar priorities, are fundamentally about innovation. Innovation to what end? Innovation to drive costs down, whether we're talking about hydrogen, biofuels like SAF, batteries, electric vehicles, really doing that innovation to help drive costs down so that you can then ultimately have market pull for these different technologies. Focused a lot on secure domestic supply chains as well as we're looking at new technologies that are now entering the marketplace. How do we make sure we have the critical minerals, for example, for those batteries domestically or in places where we have a secure, stable supply chain? Because without a stable supply chain, as we know, you don't then have nothing really works and cost goes up. We do a lot of work looking at impacts to the grid. As the Department of Energy, of course, that's one of our focus is making sure that the electrical grid is working and operational as more and more of the economy is electrifying in different ways. And electricity is being used, batteries for all types of things, batteries in airplanes, how do you charge those? I'll touch on that. We also have a big international focus, recognizing in transportation, as all of you know, every industry here is a global industry. Airlines are global, car companies are global, truck companies. You have in the grand scheme of things, a relatively small number of very large industrial players that all have to operate in a global context. We are very focused to make sure that our U.S. companies and U.S. jobs remain competitive in that global context. So we have to be heavily involved in there, working with groups like AIAA, for example. So, all right, I'm going to basically divide my talk this morning into maybe two chunks. First chunk, the majority of it, talking about SAF, and then the second chunk talking about things other than SAF. So I put questions I often get on SAF, things you may be wondering. Basically, where will the SAF come from? How much SAF can we make? How are we going to lower the cost to make it competitive? And what's the commercialization strategy to ultimately make all those things above actually work? Then a little bonus, we'll talk about what else, as I mentioned, we can do to help improve efficiency overall in the aviation space beyond SAF. So let me start first with maybe the big picture. This is a graph that shows emissions over time, historic, and then future. This is if you go to a KO and look at the overall aviation plan for the U.S. You'll see this in here. But I want to address a few big things. Some people said, well, is the U.S. still focused on SAF? Absolutely. Executive Order 14154 on energy dominance in the U.S., spelled out a lot of things, but a few really big, high-level things. That the U.S. needs to focus on increasing its energy options, has to grow its energy footprint, focus on domestic items, and specifically that biofuels and SAF are a critical part of that. That lays that out very clearly in that executive order in this administration. Our part here at DOE fundamentally is how do we develop the innovations to make that happen, especially around lowering cost, enabling scalability going forward. So, when you look at this chart, if you look over time, kind of if nothing happened, right? If you froze the whole world back in 2019, what would it look like? You have diffusion of existing known aircraft technology, but that diffuses over time. This out to 2050. Improvements in new aircraft, improvements in efficiency. You could dicker with the exact point of any one of those lines, I'm sure, but the overall message is that if you want to have substantial reductions in emissions, and again, ICAO has set global targets, airlines, U.S. airlines have set targets for emission reductions. If they're going to achieve those, you have to have SAF be a big part of that uptake. And, of course, getting to zero is probably more theoretical and ambitional than anything, but no matter what you do, SAF is going to have to be the really big player. And there's a lot behind that, that chart when you look at where the opportunities could be, what other things could be in there. I will talk a little bit about electrification and hydrogen as well. Those might be as much a time frame issue as anything. So how are we approaching this? If you have not heard, back about 5 years ago, we started something called the SAF Grand Challenge. Fundamentally, it was a way to say, if we're going to tackle really big issues, like how do you get a new fuel into aviation, you have to have all the government working together. Everyone's got to be rowing in the same direction, right? We can't be going off in different paths. So we have to be collaborating closely. We have to be working closely with industry. We have to have a goal or target. Like, is this scalable? We basically, at that point, working with airlines as well, said, could you get to 10% in 2030? What would that look like? How would you do it? An ambitional goal, but key thing is, how do you then develop that technology, reduce the cost, get the scalability, help create export opportunities for fuels? I'll speak a little bit to that in a second, where the current import-export market is on SAF. But as there's global demand for SAF, we are seeing export opportunities for fuels. Again, going back to that, overall priority of growing our energy footprint, increasing our global competitiveness. This provides, SAF Grand Challenge provides a place to convene the experts as well, like I said, across industry and government as well, to address all the different issues around aviation fuels, addressing the infrastructure questions, addressing the fuel specs and standards. Those will have to be revised and changed. How do you get to better than, over 50% SAF mix in fuels? Those types of questions. So let me hit a few points here from, again, from our perspective, the Department, where will SAF come from? One of the beautiful things, right, about SAF is that, it's being made from essentially, I like to think as waste carbon resources. How do you take carbon we have that otherwise would not be of value, right? Finding with hydrogen, you're making a hydrocarbon fuel ultimately. But you're tailor making that, right? You can adjust that spec of that molecule as you're looking at what it wants to be. But when you look at that waste carbon, right, that's biomaterial, but it can be biosolids, it could be plant-based, it can be from municipal solid waste, can be waste carbon from CO or CO2 as well. All of those sources. When you think about the terrestrial-based resources, we have it all over the country. And it varies in what part of the country, which type of resource is dominantly available. This is diversification. This provides opportunity for a broad range of fuels across different parts of the country and help support the agricultural community, farmers, as part of that process overall. When we look at the amount, so that's a bit of the where, the actual amount, let me do a little bit of a build chart here. We published a study called the billion-ton study. We just published the third iteration. It's been done about every 5 years, done through the U.S. national labs with a lot of consultation with a lot of different folks. And we look at basically how much available biomass resource would there be in the country without impacting food, without using any of that food-based crops or material. with realistic growth numbers, realistic, resource potential, things like that. So let me walk you through what this says overall here. It's a bit of a build, as you can imagine. So currently about 342 million is what we have towards tons, towards that billion tons. That's what we have today. You can see what it's made up of: agricultural, a lot of forest wood waste, and that's forest when we talk about it. It's not just in the forest. We have huge pulp and paper forestry industry. A lot of that processing of that wood, you get a lot of waste material there, right, at those factories, and then municipal solid waste. So you look at, we look at what is near-term available, what is a mature market, low and medium, and then what would, if you look at a growing or emerging market, what are the different possibilities? So current base, 342 million, right, across all of those. Then grow that. What's currently available, we think in the near term can double. Just in the near term among that currently available without having to go and do all new types of crops. And you can see in here where that comes from between new areas, so the currently used, but also waste, forest, ag residue. Ag residue, when you think about that, when you're growing crops, again, a lot of non-food part of the crop hits the ground, if you will, literally. It has to be processed and dealt with. So if you look at a mature market, as the market is growing, so recognizing we're not going to need 1 billion tons tomorrow, but if by 2050 we want to have a slow, steady growth in this market, how does it grow? You can see here a few different scenarios of how high you can get it and from what sources, but up to 440 to 880 million tons of biomass, depending upon your yield assumptions. Importantly, what you see here is this group here of energy crops. Energy crops refer to places where on fallow land, on marginal land around agriculture areas, not replacing existing land, not using all new virgin land. You can grow purpose-grown crops that are well made to be energy crops to be converted over into biofuels. And that provides added economic opportunity, right, for farmers as well. It also can help a lot with soil management, I will say. One of the critical issues if in agriculture is that soil management and having the right, nutrients, ingredients in the soil. And you can, if you're smart about it and think about how you do this with biofuels, you can actually help with that. Also help with, there's a lot of soil organic carbon, right? That's one of the biggest sinks of our carbon is in the soil. And how do you manage that as well as this process overall? And then this last piece shows with microalgae and algae. It's often talked about, people ask what the opportunity is. It's a good size, but energy crops just have bigger now. Maybe at the end we don't use all of that and we do more algae. Hard to say which one of these exactly will be the lead one. But the point is that we have been studying and looking at in great detail, and these studies have stood the test of time in both accuracy and reviews, say what is that resource that's available. I do think it's worth noting this would vary for every country, right? This is not a universal piece. Each country has its own agricultural base, its own land base. So that's one of the things as we think about SAF, when we think about it on a global basis, we do have to recognize that the resource availability may differ. In the United States, this is a huge opportunity. This is a big resource we have. It is something that we can produce and it is something that we can also export. I want to emphasize this last point. It is everything we do focuses on sustainably produced, meaning not using, and there's a lot of questions, well, aren't you taking waste? Aren't you taking too much water? We've looked at all of those with these studies. And it's lower actually water use than other energy production ways. A lot of energy uses water in one way or the other. You need water base. So we've taken that into account, and again, not impacting at all food supplies. So, okay, so if that's where it's coming from, how much actual of the SAF can we make and how much do we need? So I'll walk you through a way we look at it. This is the total fuel use, the year, let's see, this is projected out to 2050. So just to say, given anticipated growth in a more or less business as usual way across the different pieces, we use on the order of 200 billion gasoline gallon equivalent. It's all in gasoline gallon equivalent, just to have a common look at it. So you can see at the top, light duty vehicles, then medium duty vehicles, off-road, which is actually bigger than a lot of people think, agricultural, construction, things like that. And then aviation is the second from the bottom, and maritime. So that's how much we need billions gasoline gallon equivalent overall. So if you blow up just that bottom section, right, just so we can focus in on that, there's about 60 or so, 65 billion gasoline gallon equivalent we need across the non-on-road sectors. So put light duty and heavy duty aside, say, okay, that's a big chunk, of they're going to need a different solution for fuel choices. You now look at that billion tons I talked about, and you say, how much fuel can you make with a billion tons? That basically shows you where you are. It's on the order of 60, 65 or so billion gasoline gallon equivalent. You can see the each ton of material you have converts at different rates, so you can see how much actual you get. So starch, that's ethanol. That's today. Corn, we take corn today, and 10% of all the fuel we use in cars is biomass, right, from corn ethanol. Starch, vegetable oils, agricultural waste, forestry waste, big energy crops, municipal solid and wet waste, so biosolids and algae. So if you were going to, out 2050 can be converting that billion tons, growing that and converting it, this is how much fuel you could make. You could cover all of aviation in the United States. This is a forecasted of what the aviation fuel use would be out in 2050. You could cover some portion of other sectors as well. So is there enough that we could make? Yeah, there is. Not tomorrow, but over time, right, if you're going to grow that. And then our sense of how that grows, you don't do a little of everything all at once. You start with easier things, and you move your way up. So today, fats, oils, and greases are already being converted to fuels. Corn, starch, easy. Those are both the easiest process-wise, cost-effective. Moving that into municipal solid waste and wood waste, agricultural waste, and then energy crops and algae. We see that from a time frame, and this is how our R&D is focused. We did a lot of work on cornstarch and fats, oils, and greases 10 years ago to allow the market to be where it is today. We've been working a lot on municipal solid waste and wood waste the last 10 years on the actual fundamental, the chemistry, right, the biochemistry and how you convert that. And we're growing our work right now on looking at energy crops and how you grow those and the time frame and how you get that to be efficient. So our goal is to be always, looking about 10 years ahead to where the market is today, to be developing the technology innovations and to allow the time for the market pull. So today, something that surprised me, the U.S. is actually the largest producer of biofuels in the world. A lot of that ethanol, but biodiesel as well, renewable diesel. And then you can see SAF starting there, a few green dots just starting up. But there is a large number of biorefineries today in the U.S. In fact, I'd like to look at, so one of the questions, again, part of pressure checking, is this a feasible strategy, right? That was kind of the question people asked me to address today. Is it a feasible strategy to think we can move towards SAF for the entire aviation industry? So if you look back in time, that's a picture on the left of a biorefinery. Look at what we did with ethanol. We have on the order of about 200 biorefineries today. They can be made of different sizes, so the number of refineries maybe is a little harder than the total gallons. But we would need about 400 to 500 biorefineries by 2050. Is that realistic to think about? So if you look at history and look at what we did with ethanol over and I looked at how long did it take to build that out. Over a 10-year period, we built out 15 billion gallons of ethanol in the U.S. through biorefineries. So that means not just the refinery to make it, but you got to get the biomass to that refinery. Different biomass is easier or harder to move, easier or harder to store. That turns out to be one of the critical parts of looking at this. And we have a whole research arm just on how do you take the biomass from wherever it starts, get it to the point you're feeding it into an industrial process at a biorefinery and doing that consistently at an industrial scale. That's where a number of projects fall down. But we did that, and there's a lot of work DOE helped support, 15 billion gallons at a time period. So we basically have to replicate what we did over the next 30 years. So it's not impossible. We did that. We grew that. It provided a lot of jobs and opportunities here in the U.S. We have to continue doing that now with a focus on these new SAFs. One example, I'm actually in that picture somewhere, I believe. This was LanzaJet's facility down in Soperton, Georgia. They are the first place that are doing ethanol-based alcohol to jet, commercial plant. That is a plant and a footprint that can grow quite a bit. It's a style and design that could be replicated quite a bit as well. So alcohol to jet is one of the, we think, primary pathways in the midterm when you look at it. So we know how to get to the alcohols from the biofuels, and then you go alcohol to jet in the process. And when you think about this challenge that I was mentioning about the feedstock, one way to think about it is rather than having your biomass feedstock from where it's starting, a lot of places, and going to one place and out comes SAF at the other end, you have it going to the intermediates like ethanol or alcohols, which have many industrial uses as well, right? And then you have those intermediates that you can ship in volume to a facility like this that can do the alcohol to jet and be processing in big volumes that you need at a type of refinery if you're gonna support the entire US aviation industry. So how are we making SAF lower cost? That was one of the other key questions here. As I mentioned, this is the heart and soul of the work we do at DOE. We work on, we use the largest supercomputers in the world that we have at the department, using AI technology, not just in the last year or two, but really for the last 10 years, developing that to develop new chemistry, to develop new enzymes. So it's both biology and the biochemistry, and then to some degree the actual processing. At the end of the day, if you're going to get that cost down, you have to focus on every part of the biorefinery. You got to first, you got to look at where you're taking the biomass or waste carbon in. You have to be working on that pretreatment, and there's different things you can do there to lower that cost, reduce the amount of heat you need. Right, that becomes one of your big cost drivers, reutilizing the heat in that process. Looking at the intermediates and the ultimate conversion and what conversion technology works. Part of the answer is there's not just one way, right? As you have different biomasses, different types of feedstocks, there will be different conversion technology. There'll be different types of biorefineries that will make sense. So that diversification is both the challenge maybe and the opportunity when we look at this. One thing I do want to point out, when you look up here, CO2, if you have in an alcohol to jet, any fermentation process, as you have CO2 coming off, this is the best example of clean concentrated CO2. This is clean concentrated, recapturing that and going CO2 to fuels makes a lot of sense. There's certainly CO2 sequestration from that as well being worked on. One other thing I want to point out is when you look at the economics, I should have put this chart in there. If you look at a barrel of petroleum today, what happens? Where does it go? The majority, the vast majority of it, 70% of that goes into fuels to move vehicles. A small percent of it goes into chemicals. But profit-wise, a big percent of profit comes from those chemicals, specialty chemicals. It's like a lot of things. You have the volume part that has high volume but lower margin, and you get another part that's lower volume but higher margin. You need it all, though, because you can't get one without the other. Same thing will be true in a biorefinery. Those bioproducts and those biochemicals and biointermediates are going to be part of the economics of how you lower that cost and how you make it work at a total system level. The other, from a commercialization strategy, this goes to how you lower the cost. This chart walks through how we think of it. It's a TRL chart, essentially, and you look at the work we do. We do bench scale work, all at the very TRL 2 and 3, and then we grow it from bench scale to the next level of reactors, kilograms a day, and then looking at pilot plants where you're talking tons per day, and then demonstration, and then first pioneer plant. We have been funding now for a number of years, certainly a lot of the bench scale, a lot of the process development unit. We have capabilities at our U.S. national labs. NREL, Scott's from, has significant, more than just bench level, but much bigger scale as well. And we have funded all the way up through first demonstration scale. We know that when you're talking about processing liquid fuels, at every step, things change. As you grow volume, you can't necessarily, what worked at lower volume, as you change the volume, things change. Time in the tank changed, small temperature changes. You need to grow with the volume, prove the technology out all the way up to the large scale. And that is what we have been doing. That's why you're starting to see now more and more biorefineries, bioproducts coming on board. It takes time to walk through this. But that is where we have been focused and had success. So when you look at progress, this is through, let's say this was pulled last year, so through September 2024, SAF volumes in the US. I mean, obviously you see big growth. Total volume is still relatively small compared to demand today. But I think one of the other interesting things is look at the blue versus the green, imported. Starting in 2022, we started importing SAF. There's a demand for SAF here that can be met. We also, through the SAF Grand Challenge and through that whole team analysis, we published a major report, let me think now, last year, looking at the capacity in the US. Basically, when you looked at that, it basically said of all the projects that are in the ground, in the works, and announced, there was enough capacity capable of meeting 3 billion gallons, which was that 2030 goal. So announced projects, now announced project doesn't mean the project happens, right? So some of that maybe won't happen, but there's also some time for new projects to come on board. But that was a huge, huge point. There is a continued uptick in here. There was an extension of the 45Z tax credit that was passed by Congress, signed by the president. That also helps put, keep some wind, if you will, in the sails to help get that industry going as they're getting those first plants going and they're getting to larger scale volumes as well. But we see, and we do know now that there are some export projects going that are starting up, and we think those are going to be growing as well. We do think that over time we will be a net exporter of SAF in this country. All right, that's my story on SAF, what we're doing, why we think it can work, why we think it's a good strategy, why we think it's worthy of U.S. government spending time and effort working on it. And I think for all of you, that are in the aviation industry, whether you're on the, aircraft, airframe side, on the engine side, on the infrastructure side, this is going to take a partnership, right, across a lot of people, and there are a lot of people working on SAF. We believe that future is bright and that it can work. I do want to touch on a few other things that we are doing. This is going to be just a quick tour. The U.S. National Labs, if you don't know, are part of the Department of Energy. There are, 17. There's about 5 or 6 that my team works with extensively. So one of the things we've been doing is using AI initiatives and digital twins to help improve efficiency at airports. We started with Dallas-Fort Worth through a digital twin project that has paid real dividends to reduce their overall energy footprint of the airport and the airport operations. And we are now working to take that and develop it into tools that can be used for multiple airports, from small regional airports to other large airports around the country, and that don't necessarily need you to run the supercomputer over at the National Lab to make it work. Batteries and aviation. So there are many more experts here than I am, right, on the propulsion side of aircraft for sure, but we are working very closely with our colleagues at NASA on the batteries needed if you're going to have significant large-scale hybridization. So talking here really about larger aircraft, hybridization of those aircraft. We do believe that we can get the battery densities to a point, the safety to a point where you can have significant hybridization, then that can be part of how do you improve that overall air efficiency by hybridizing those planes. My team at DOE is the primary team developing battery technology across the United States and really the leaders globally. 2 of the 3 Nobel laureates that won the Nobel Prize for the battery work are from our team and work with us. One passed away recently, the other's still alive and still working with the projects with us. So my point is, when it comes to batteries, we have been at this for decades. The improvements that have been made in batteries have come because of continued work on the chemistry, the electrochemistry. And when I talk with that team, we are not anywhere near out of spirit. We have not plateaued. We have a lot of opportunities, a lot of different ways that the team is working to try to drive up that battery density. In some cases, some uses we're now at the point where the densities are sufficient. You're focused on other factors. In aviation, obviously, we need to get those densities up. We don't know yet a way. We recognize, 1,000 watt-hours a kilogram is a big stretch. That we don't have a path known, but it's not that we're saying it can't happen. But 500 to 750, far more in the realm of where we see in the midterm that there's potential to get to. I just want to finish on eVTOL. Obviously, a hot topic in general. batteries needed there. One of the things we are working on is if you're going to have eVTOL in any significant scale, what's the charging going to be? Getting back to this, it's got to be practical. So part of what we're doing is we're working with some package delivery companies and eVTOL companies to say, how do we standardize this charging, megawatt level charging, maybe slightly lower than megawatt level, but where you have both package delivery trucks, eVTOL, that's an industry that could work together, right, commercially, but have the same charging that you'd use for both of them, and developing those types of charging standards. It's not the sexiest thing maybe, but it's important. If you don't have that infrastructure, if you don't have that worked out, how are you going to get it done? I want to touch on hydrogen. Hydrogen is always a hot topic in aviation, I think. Hopefully not physically hot. There is definitely, so my team is responsible for the US hydrogen work, hydrogen production, fuel cells, hydrogen strategy. So we lead that work for the US. There is certainly a lot of talk, I recognize, on the potential for hydrogen in aviation. I guess I do want to point out, though, there's a big difference. I chose these two pictures for a reason. There's a big difference between a kind of prop-based fuel cell plane like that and saying, I'm going to make an all-new, radical different airframe that for hydrogen, which we believe if you were going to really do large scale, you would need to really fundamentally rethink the entire airframe concept. That's a big deal, obviously. So I will say at the moment, hydrogen in aviation is not a big focus. We're focused really on how do we reduce the cost of hydrogen and produce it at scale, because if we can't produce it at scale, at low cost, at low emissions, then what's the point? There's also a lot of different people that want to use hydrogen. One of the biggest uses for hydrogen in every forecast we do is actually the biofuels for the SAF. Remember, it's a hydrocarbon, you need hydrogen in there. So the biggest new use we see, one of the biggest, is for making biofuels. So I also recognize, I think, for hydrogen in aviation, there are a lot of challenges that would have to be addressed. Not that they can't be, and not that we shouldn't be. We talk a lot with our colleagues at NASA about this regularly. I think it's something we have to be keeping our eye on, working on, but also recognize we just don't see it in the, in this, say, mid to time frame at all. If it comes, it's a longer term piece. I think the larger hydrogen economy is something we're still working to solidify that can happen. Then can we get to a fuel in aviation? So not to say you won't see it, but our sense is it's just not a priority versus what we're doing with SAFs at the moment. So overall, here's my, the challenges here are big. Whenever you're talking about a huge industry, aviation, global industry, obviously safety factors that have to be at the absolutely highest level. Huge commercial interaction with people's lives every single day. Most of us flew to get here. People fly all the time. If you're going to make a really big change, like let's change the whole fuel source for that. That's a huge deal. Now, moving to SAF in some ways is a relatively easy move compared to, let's say, another industry that maybe is going to say, I'm going to go from a liquid fuel to a non-liquid fuel. That's a really big deal, right? So moving to SAF, obviously, given the challenge in the industry, the fact you have flexibility to blend SAF with current Jet A, the fact that you're still maintaining that liquid fuel, you have a lot of things there that are going for you that make it a much easier push, solve a lot of infrastructure challenges that maybe in other sectors we can't do. But that's why we also think, some people ask, well, why wouldn't all this biofuels just go into cars? You go back to that first chart I did, with 1 billion tons, we don't have enough biofuels to meet the energy needs in vehicles. You just don't. There's not enough of it. So that's not a strategy that will work. We do have enough to cover aviation. Aviation also doesn't have other good alternatives to really take care of that volume of the business. Not that there won't be electrification or maybe hydrogen at the margin, but for the big volume. I think, hopefully the technology exists to get there. It's really about scaling up now and bringing costs down. Lots of work to be done, a lot of challenges to solve, as I said, but I think the technology is there. This is not a mission impossible thing that you can't get there. It will take a lot of continued innovation, which is where we at the government come in, working closely with industry, though, as well, on every part of this, which is partly why I'm here, right, to make sure people in the aviation industry know that we at the DOE are here to partner with you, work with you, and that we recognize we do need to work together on that. All right, with that, I'm going to wrap up and wanted to make sure we leave. We got a good 20 minutes, I think, here for Q&A. I was told that this group likes to ask questions, so hopefully we'll be able to get some there.
Great work. Okay, so we're moving to Q&A. There should be a QR code that pops up here very quickly.
Do I need to do something here?
No, I don't think so.
Okay, I'll replace it there.
Jim, do you have it? Okay. So we've got a few minutes here to kind of take questions from across the group here. Michael, thank you for providing that broad overview. It's always interesting going from the Department of Energy perspective to the aerospace perspective.
Yeah.
And working across between those. We're like, wait, what if we did it this way? One of the things I wanted to make sure, Jim asked me to make sure to say thank you.
Excellent.
With a AIAA challenge going.
Thank you. We have lots of challenges to do, so thank you. Very appreciated.
Okay, so with that, we are looking for questions. Can we get to the next, go to the next prompt, please? Okay, looks like we have one more thing to cover before we get to that. Some things just to note before we go into Q&A. You're going to have a Wright Brothers lecture in aeronautics occurring today. It's happening over lunchtime. So if you can grab your lunch, come back in by 11:45, you can hear Susan Ying deliver her lecture on emergence of hybrid electric aircraft. And also, you've got the exhibit hall and going on at the hub as well. So here are some of the things that we have going on today. Okay, now we're to Q&A, I believe.
I think she's saying open up the iPad. There.
Okay, there we go. Thanks, Monique. Thank you, Michael. So you've got the QR code. We can get it going. And looks like we already have some questions coming in. From the QR code, you can like certain questions if you want those asked first. And we can kind of run through those. Let's just start looking to see what we have. People are starting to actually
there we go. I see.
Give some opinions.
Okay.
Okay, well, let's start with one of the first ones that's getting some attention, okay? Assuming no free lunch, does higher utilization of agricultural and wood waste have any potential impacts on the ecosystems we need to plan for?
Yes. So assuming no free lunch, do we have? Repeat the question again. Is there?
I think where it is headed is to say if we are going to use our wood waste and our agricultural wastes for fuels, is there another impact that's occurring?
I mean, there's positive impact. Currently, that those waste have to be dealt with somehow, right? So if you're in the pulp or paper industry or in agricultural, a little different in both cases, right? But there's actually a cost to deal with that waste. So now you're actually taking that waste, and this is the part that's not being used for other things, and being able to now convert it over to fuels. I will say one place on the forest waste and residue. So there's off the pulp and paper industry is one. But then there is the actual forest residue on the ground. And as you know, we have big forest fire issues. We do have a number of projects going with Forest Service looking at how do we basically help address fire risk by getting that waste off and then converting it to fuel, because there's a cost to getting it off. And if you have now a fuel that you can make it out of, so there's positive there. I will say, in general, maybe I'll expand the question. What are the unintended consequences of using these different resources? That is something we focus a lot on and understand what's happening with that waste now. What is it? Is it being used as part of the ecosystem in the farm for, for nutrients or other things, right? Then you don't want to disturb that. In many cases, it's actually a problem in that it is, but it's not being done in the ideal way. And if you're actually pulling some of that waste off, you can actually improve that overall nutrition, soil nutrition. So that is something we look at and take into account. You obviously want to avoid things like what, it's happened in certain places, palm oil, where you basically take land that's forest land, deforest it to put things. So in all of our studies and looking at what we do in the U.S., that is not, that's obviously not assumed, or it's very explicitly like, you're not taking any virgin land like that and displacing it.
Thank you. Okay, you have an overwhelming request. Okay, this one is, how has the administration change impacted your outlook and optimism on, and what a likely progression of SAF is?
I think, as I mentioned, I specifically quoted the executive order on energy dominance because it very clearly articulates in a way that's more clear than it ever has been in my time in government, at least, that SAF is a key priority. So I think it is very clear from this information that biofuels and SAF supporting farmers is a big priority. They have really articulated that clearly. I see that day to day in the work. That's why I'm here today talking to all of you as well, is to share that as well. So I think there's support there. I think the fact that there was continued support in the bill passed by Congress recently, signed by the president, adjusting the different tax credits. SAF is one of the ones they continue on. Now, they made changes in there, but continued on, extended it. Also, I continue to be very optimistic about the innovation capability. None of these things happen just because you will them to happen. It has to be something that changes, right? We're trying to drive a change to happen. And in my view, this is my philosophy, things that you happen at big scale happen because there's some technology change. And we continue to have technology improvements, technology innovations to help grow the amount of biofuels that we can convert economically. Computing power and computing and AI improvements are a huge factor. Why can we do something today we couldn't do it 10 years ago? Well, part of it is we can do things a lot faster. We can do that computing so we can analyze millions and millions of combinations that we never could have before of a particular chemistry or enzyme to target in on what's the ideal one. So those types of changes give me a lot of optimism.
So we've got another kind of question of kind of near term, long term. And the question, it comes in two different forms, came in, but the same request essentially is, we're investing heavily in SAF. And it's now, at least the person that wrote this considers it a transitional fuel. So why go into a transitional fuel rather than go all in on future energy carriers like electricity or hydrogen?
In my job, a lot of it is like looking out at what technology can be, right, in the future. And that's hard to know. You can't know. I mean, it's possible to know. But I think when you look at the time frames here, and you look at the entire ecosystem, the infrastructure, airplanes, safety margins, all of those things, SAF is an achievable level, whether it's a interim or long term, and are we talking 50 years, 100 years? What's long term? I think it's really hard to say what in 100 years will be the way that people are moving in aviation and flying. But you look at the type of change it takes for the airframe side for some of these other fuels, the energy densities that are needed, there just aren't obvious pathways to get the bulk of the fuel. When you're talking about where fuel is used in aviation, it's long haul, it's at cruise, it's not these smaller flights for the bulk of the volume. And having a solution that only works for part of it, or having two solutions that need two massive new infrastructure pieces, it's just going to be hard to get to. We need to improve battery densities a lot just to get to the hybridization. And again, at hydrogen, we have a lot of other challenges, I think, before we could say, yeah, it clearly can be the fuel to take the whole bulk of all of aviation. That's a big volume, right? So not that you can't do it a little bit at the margin, but I think if you're looking at the bulk and the big volume, makes sense to invest in SAF. It's not a 10-year interim, right? It's like you're talking 40, 50 years, and then we see where we go.
And it gets to fleet replacement as well, right?
Yep, absolutely, exactly.
How quickly can those aircraft be modernized?
Yep.
We've got another question that kind of goes to unintended consequences. And this is a question of, if we put more batteries and those chemistries into these vehicles, their second or third life, are we causing another problem with disposal?
I think it is interesting. If you think really big picture, we have been in an energy world, right, where we have the energy and we consume it, right? Combustion, consume it. Now you have gases that come off of that. But at the end, you've consumed it. If you think about batteries, if you think about wind or solar, right? At the end of it, life, you eventually have that old solar panel, you have that old wind blade, you have that old battery. So you have to be thinking fundamentally about, in this change of energy, how do you deal with those materials? In the case of batteries, we have a very large program on battery recycling because it is the best source of critical minerals we have in the country. When you forecast and look out at battery use, and every forecast, the vast majority of that volume, by physical volume, is in vehicles, some in energy storage, but the volume is in the vehicles. You start having enough of those batteries that you can reclaim those critical minerals, and rather than taking a critical mineral, digging up the ore from the ground, grinding it up, moving it, processing it, getting to the mid-level, you've already done all that in a battery. You can reclaim it to a mid-level stage, and we have it here domestically. Whereas today, a lot of the processing of critical minerals happens overseas. We'll bring more of that in domestically. One of our core critical mineral strategies of the country is battery recycling and using those. So it will actually be part of that resource in reuse.
That's great. That's great. Another discussion that's coming up is a question of water. And assuming we're going to get to the 2050 goals, is there enough water to support SAF and the crops and everything else that goes with that?
So the answer is yes. So when you think about, first of all, you're using a bunch of waste things where you've already used water. Think about maybe simplest one people can kind of think of, like corn. You grew the corn, that water went in, a bunch of the water went into the end product, the corn kernel, but a lot of it went into all the other biomass, right? So it's already there and it's already been used. So you're not talking necessarily about new ones. If you're talking about energy crops or let's say algae is a good example. Algae you can actually use not necessarily fresh water, right? So that's a good use there. When you talk about energy crops, you also have in many cases, if you're doing this on the edge of marginal land, you already have a lot of fertilizers and water there that you're using that you can use. So when you look at that whole water picture and you think about the alternative, you use a lot of water to make energy today. So it's a trade-off, right? There's every form of energy has different pluses, minuses, ways you're making it. This is one you have to take into account with biofuels, but actually it turns out not to be a relatively big negative compared to others.
This goes to kind of the economics side of things. Thank you for all the good, detailed questions that you're getting for this group, first thing. So this gets to the question of the economics, and it says, why would an airline or an operator buy SAF instead of jet fuel? Now, I think this goes to the question of cost. And do you anticipate more regulatory restrictions or supply constraints on petroleum products?
I think I don't anticipate those here in the U.S., but I think globally there are ICAO has set global emission reduction goals. U.S. airlines have set those goals on their own. That's as well to say where they think they need to get to. I think our job is to provide what are technical options that they have on the table. At the end of the day, right, they'll have to decide they want to do that or not. We are aware, though, with the global marketplace, and there is a global push to reduce emissions that you cannot deny. So recognizing that, one thing it does is it creates a fuel opportunity for us. Take advantage of that. We are blessed as a country to be able to produce biofuels more than many other places in the world. They're not the only country, but there are others, and take advantage. And believe me, in a global political environment, other countries that are agricultural positive are absolutely thinking about that. It is a competitive global issue there. So there's that reason as well for us to keep going. I think, in some cases, I think we can get the cost down. Can you get the cost to be exactly the same as petroleum jet A today? One of the things that's interesting, if you look at petroleum or jet fuel prices, right, there's a lot of variability over time. A lot of reason to believe that bio-based fuels are going to be much, much more stable, and there's a risk premium with variability. So, you take that into account. That can help on the economics as well. And And then, our job is to try to just drive those economics down to be as close as possible, and, make sure people are competitive. I do think we can get it to be competitive. But yeah, at the end of the day, it will be an airline's decision or choice, right? In that global context, though, as they're flying globally, what fuels they use.
Yeah, makes sense. Another place we go, similar discussion on this, and let's see if I can summarize this. Aviation has sustainability goals that are heavily dependent upon future SAF. And the cost and production is controlled by another industry. How can the energy industry become a reliable partner to reach aviation's goals?
I mean, I don't know if there's any industry system that's completely self-contained, right? Really, when you think about it. Any industry that uses electrical power for anything, right? You need a lot of electricity, make aluminum, make airframes, or, carbon fiber. The carbon fiber is coming from, petroleum-based products, a lot of cases as well, and then a lot of energy in there. So I guess everything is always intertwined. I think that one way to think about this, or the big picture, is there is some reality to the question of it takes offtake, right? If someone's going to put the investment to make a new biorefinery, they have to be confident there's a person to buy that fuel. That's probably where it comes together. I think we are developing the technology to make it capable to happen, to bring these parties together. There's a certain amount of the marketplace having to work there of people basically say, okay, I will guarantee enough demand to then say, okay, we can now justify or track the investment to build the physical facility. I think it's pretty interesting, there are groups out there doing demand aggregation. You have a classic chicken egg problem in a lot of cases early in an industry. You can see this could work at the nth stage, but how do you get those first movers going? Who takes that first risk? And one way to minimize that is aggregating demand, and there are different groups, NGOs, companies that are trying to aggregate demand so that you have enough demand to support initial production that can lead to the next production that can lower costs and then get the system to build on itself. So I think that's part of how that will happen.
Thank you so much for all your time today.